Mount Etna is not just a volcano. It is a living, breathing titan that has dominated the skyline of Sicily for over 500,000 years. But right now, something is happening that has the global scientific community on high alert. For decades, we have watched Etna erupt with fiery displays of lava and ash. But the real threat might not be what is coming out of the top. Instead, it is the mountain itself that is moving. High-precision satellite data and underwater sensors have confirmed a chilling reality. The entire southeastern flank of Mount Etna is sliding into the Mediterranean Sea. This isn't a slow geological crawl that takes millions of years. It is happening at a rate that suggests the structural integrity of Europe's most active volcano is beginning to fail. Scientists are now sounding the alarm about a potential catastrophic collapse, a massive landslide that could displace billions of tons of rock into the deep sea, creating a ripple effect across the entire Mediterranean basin. The window of observation has shifted from curiosity to urgent monitoring, and every millimeter of movement counts. To understand the scale of what we are talking about, you have to realize that Mount Etna is one of the heaviest things on the surface of the planet. It towers over 11,000 feet above sea level, and its base covers an area of nearly 500 square miles. For a long time, geologists believed that the movement of Etna's flanks was driven solely by the internal pressure of magma. The idea was that as magma pushed its way up, it forced the sides of the volcano outward. While that is happening, we now know there is a much more powerful and much more dangerous force at play: gravity. Recent studies using seafloor transponders have revealed that the volcano is sliding under its own weight. This process, known as gravitational instability, means that the eastern side of the mountain is essentially losing its grip on the basement rock. It is a giant pile of volcanic material sitting on a slippery slope of ancient marine sediments, and gravity is pulling it down toward the abyss. Why did this news break just moments ago in the world of scientific discourse? Because the rate of movement has shown a sudden and unexpected acceleration. While the average slide has been about 2 to 3 centimeters per year, recent measurements at the coastline and beneath the waves show shifts that are significantly larger. When a structure as massive as Etna starts to move unevenly, it creates internal stress fractures. Think of it like a skyscraper, where the foundation on one side is slowly sinking into the mud. Eventually, the tension becomes too much for the material to bear. This isn't a theory. We have seen evidence of this in Etna's own history. Thousands of years ago, a massive portion of the mountain broke away, creating the Valle del Bove, a giant horseshoe-shaped caldera that looks like a bite was taken out of the volcano. If a similar event happened today, the consequences would be felt far beyond the shores of Sicily. The primary concern for researchers at the National Institute of Geophysics and Volcanology is the transition from slow sliding to a sudden collapse. In the world of geology, this is the ultimate nightmare scenario. When a volcanic flank collapses into the sea, it doesn't just sink quietly. It moves with a speed and force that can displace a massive volume of water. We call this a landslide-generated tsunami. Unlike tsunamis caused by earthquakes, which give us several minutes or even hours of warning depending on the distance, a landslide tsunami happens almost instantaneously for the immediate area. The energy released would radiate across the Mediterranean, potentially impacting the coasts of southern Italy, Greece, North Africa, and even parts of the Middle East. This is why the monitoring systems have been upgraded to provide second-by-second data. We are no longer looking at decades. We are looking at real-time stability. Let's dive into the technology that allowed scientists to detect this shift. For years, we relied on GPS stations on the mountain's surface. But those stations move with the landslide, so they don't always show the full picture of what is happening underwater. To solve this, a team of German and Italian scientists deployed a network of acoustic sensors on the seafloor, along the volcano's submerged flank. These sensors send sound pulses to each other, measuring the distance with millimeter precision. If the distance between two sensors increases, it means the flank is stretching and moving away from the stable part of the crust. The most recent data retrieval from these sensors suggests that the submerged part of the volcano is moving even faster than the part above sea level. This is a crucial discovery because it proves that gravity, not just magma, is the primary driver. If it were just magma, the movement would be greatest at the summit. But because the movement is happening at the bottom, it confirms the mountain is structurally sliding. What does this mean for the people living in the shadow of the volcano? On a day-to-day basis, Life in Catania and the surrounding villages continues as usual. The residents of Sicily are used to Etna's moods. They see the smoke, they hear the rumbles, and they sweep the ash off their balconies. But this new warning is different. It is not about a lava flow that moves at a walking pace. It is about the subterranean stability of the land they stand on. Scientists are working hard to communicate that while a collapse is not necessarily imminent today or tomorrow, the risk trajectory has changed. This is a long-term geological threat that has entered a more active phase. The challenge is that predicting when a slide turns into a collapse is one of the hardest problems in Earth science. It is like trying to guess the exact moment a sandcastle will slump as the tide comes in. To get a better sense of the scale, imagine a block of earth and rock 10 kilometers long and 5 kilometers wide. That is the size of the piece of Etna that is currently on the move. Now imagine that block sliding into the water at over 100 miles per hour. The sheer physics of that event are mind-boggling. The friction would generate enough heat to boil the surrounding water, and the displacement would push a wall of water hundreds of feet high. Geologists have spent the last few months running computer simulations of various collapse scenarios. Some show a partial collapse that creates a series of large waves, while others simulate a total failure of the southeastern flank. The results are being used to help civil protection agencies plan for long-term coastal resilience. But the sheer unpredictability of Etna remains a major factor. Another fascinating part of this scientific discovery is the relationship between Etna's eruptions and its sliding. You see, when the volcano erupts, it adds more mass to the top of the mountain. Every time a new lava flow cools, it is like adding another brick to an already unstable pile. This increase in weight actually increases the gravitational pull on the flank. At the same time, the lava tubes and magma chambers act like a lubricated network inside the mountain. The heat softens the surrounding rock, making it more pliable and easier to slide. It is a vicious cycle. The more active the volcano is at the summit, the more unstable it becomes at its base. With Etna being in a state of near constant activity for the last several years, the loading of the mountain is happening faster than it has in centuries. We also have to consider the role of the Ionian Sea itself. The seafloor off the coast of Sicily drops off very steeply into the Ionian Basin. There is no natural barrier to stop the movement once it begins. If the flank of Etna were on flat land, it would eventually just settle. But because it is on the edge of a deep marine canyon, once the slide crosses a certain threshold, the acceleration will be driven by the steepness of the seafloor. This is why researchers are spending so much time mapping the bathymetry, or the underwater topography of the region. They are looking for pre-existing cracks and fault lines in the seafloor that could act as slip planes for the next major movement. We saw a similar, though smaller, event in 2018 at Anak Krakatau in Indonesia. That volcano suffered a flank collapse that triggered a devastating tsunami without any seismic warning. What could a giant like Etna do? Etna is many times larger, and its collapse would involve much more material. The comparison has led to a global effort to improve landslide detection on volcanic islands and coastal volcanoes. From the Canary Islands to Hawaii, the lessons being learned at Etna are being applied to save lives worldwide. There is also a chemical component to this story. As the flank of the volcano stretches and cracks, it allows seawater to seep deeper into the mountain's internal structure. When seawater hits the hot rocks or magma deep inside, it can flash into steam, creating high-pressure pockets that further weaken the rock. Scientists are monitoring the gas emissions at the base of the volcano and on the seafloor to look for signs of this interaction. An increase in certain isotopes of helium or sulfur can indicate that the cracks are reaching new depths, providing more evidence of structural failure. The air and water around Etna are essentially whispering secrets about the mountain's health, and we are finally learning how to listen. But let's talk about the human side of this discovery. For the scientists at the observatory, this is a heavy responsibility. They have to balance the need for public safety with the desire to avoid unnecessary panic. The word catastrophic is not used lightly in scientific papers. When it appears in a report about Etna, it is because the mathematical models show no other way to describe the potential energy involved. We are talking about an event that would reshape the geography of the Mediterranean. It would be a historical marker, a moment where the Earth reminds us of its power in a way that hasn't been seen in our written history. Yet the beauty of Etna persists. Farmers still tend to the vineyards on its slopes, producing some of the finest wine in the world. from the rich volcanic soil. They live in a delicate balance with a giant that gives life through its fertile ash, but threatens it through its immense weight. One of the most innovative ways researchers are monitoring the slide is through fiber optic sensing. By using existing submarine telecommunication cables, scientists can turn the entire cable into a massive string of sensors. They use a technique called distributed acoustic sensing, or DS. By sending laser pulses down the fiber, they can detect the tiniest vibrations and stretches along the entire length of the cable. This allows them to feel the mountain moving in a way that was never before possible. It is like having a nervous system for the seafloor. This technology has provided some of the most recent data points that helped confirm the 95% probability models regarding the long-term slide trends. The acceleration of the movement also raises questions about the regional tectonics. Sicily sits at the complex junction where the African plate is pushing against the Eurasian plate. This collision is what created the mountains of Italy and the volcanoes themselves. But the movement of Etna isn't just a local issue. It is part of the larger tectonic dance of the Mediterranean. If the African plate shifts, it changes the stress on Etna's foundation. Some geologists believe that a recent increase in seismic activity across the Mediterranean might be the nudge that is causing Etna's flank to slide faster. It is all connected, a giant web of rock and energy that spans from the Alps to the Sahara. We must also look at the role of climate change and rising sea levels. While it might seem unrelated, the pressure exerted by the ocean on the coastal flanks of a volcano can influence its stability. Changes in the weight of the water column, combined with increased coastal erosion from more violent storms, can eat away at the toe of the landslide. The toe is the bottom part of the slide that helps hold everything else up. If the toe is weakened, the rest of the mountain can slide more easily. This is an emerging field of study called hydrovolcanism, and Etna is currently the most important laboratory for it. What should we look for next? The next big indicator will be a change in the seismic signature of the volcano. Right now we see frequent small earthquakes related to magma movement. But if we start to see long-period low-frequency tremors, it could indicate that the entire flank is beginning to vibrate or chatter as it moves over the bedrock. This would be a sign that friction is being overcome. We are also watching for changes in the sea level right at the foot of the volcano. If the land is sliding into the sea, the local tide gauges will show a relative rise in sea level that is faster than the global average. This apparent sea level rise is actually the land sinking. The scientific community is currently in a race against time to map the oldest parts of the underwater slide. By taking core samples of the seafloor, they can see how often Etna has collapsed in the past. If they find evidence of many large collapses over the last 50,000 years, it means this is a regular part of the volcano's life cycle. If it happens every few thousand years, and the last one was 8,000 years ago, we are statistically due for another event. This historical context is vital for understanding the current warning. There is a sense of awe that comes with studying Mount Etna. It is a mountain that creates itself and destroys itself at the same time. The very eruptions that make it so majestic and famous are the same ones that make it heavy and unstable. It is a paradox of nature. As we watch the data come in today, we are reminded that we live on a planet that is constantly changing. We think of the ground as solid and permanent, but on a geological scale, it is more like a slow-moving liquid. The international cooperation involved in this monitoring is a bright spot in the story. Scientists from across Europe and the world are sharing their data in real time. They recognize that an event at Etna is not just an Italian problem. It is a global scientific challenge. The equipment being used, from German sensors to Italian satellites to American data processing, represents the pinnacle of human understanding of our planet. We are using every tool at our disposal to watch the Titan's every move. In the coming months, expect to see more research vessels off the coast of Sicily. They will be deploying even more autonomous underwater vehicles to take high-resolution photos of the cracks on the seafloor. They will be looking for fresh rock that has been exposed by the slide. This would be like finding a new crack in the wall of a house. It proves that the movement is current and active. The more we look, the more we see that Etna is a much more dynamic system than we ever imagined. For those of you who love science and discovery, Mount Etna is a story that never ends. It is a mystery that unfolds 1 millimeter at a time. The warning of a catastrophic collapse is a sober reminder of the power of gravity and the instability of the Earth. But it is also an invitation to learn. Every time the mountain moves, it teaches us something new about how volcanoes work. how tsunamis are formed, and how we can better protect our coastal communities. We are not helpless observers. We are active students of the Earth's most powerful processes. As the sun sets over the Mediterranean, the sensors on the seafloor continue their silent work. They send their pulses through the dark water, measuring the slow, inexorable slide of the mountain. Above, the summit of Etna may glow with a faint red light, a sign of the magma that continues to pump into its heart. It is a scene of incredible beauty and incredible tension. The giant is moving, the sea is waiting, and the scientists are watching. We are at a crossroads in the history of this great volcano. Whether the slide continues as a slow crawl or turns into a sudden rush remains to be seen. But one thing is certain. We have never been better prepared to witness and understand the outcome. The story of Etna's slide into the sea is a testament to the importance of long-term scientific funding and monitoring. Without the decades of data we already have, we wouldn't be able to recognize the current acceleration. It is a reminder that understanding our world takes time, patience, and a lot of very sensitive equipment. As we look forward to the next set of data, we do so with a mix of respect for the volcano and confidence in our ability to track its every move. The Titan of Sicily is restless, and the world is watching. Stay curious, stay informed, and remember that even the largest mountains are part of a world that is always in motion. We are living through a peak moment in geological history, and every day brings a new piece of the puzzle. The countdown of the flank's stability is not a reason to fear, but a reason to marvel at the sheer scale of the forces that shape our home. Etna is speaking, and we are finally beginning to understand its language. The journey of discovery continues, and we will be here to translate every rumble, every slide, and every discovery that the mountain offers. And indeed, the entire Mediterranean is written in the rocks of its greatest volcano. And as we move forward, we do so with eyes wide open, watching the slide, measuring the risk, and celebrating the incredible science that allows us to see it all. In the end, Mount Etna is a reminder that we are part of a planet that is very much alive. It is a privilege to watch such a grand process unfold, and to have the technology to share that story with the world in real time. The titans of the Earth are moving, and we are here to witness their journey into the deep.